I would like to share my experience on Rafflesia with the title, How Rafflesia Can Escape from Local Extinction. My name is Agus Susatya. I am the lecturer in University of Bengkulu and Department of Forestry. And Bengkulu is the birthplace of Rafflesia. However, before I share my experience on Rafflesia, I would like to thank to Kerajaan Kelantan and also University Malaysia Kelantan for inviting me to this wonderful symposium. And I have to say, today I'm very happy, not only because of attending the symposium, but I meet my long-respecting mentor, Professor Dato Abdul Latif Muhammad, Pak Teh, along with the late Professor Kamarudin Matsaleh, known as Pak Din. This is from Kelantan, I guess. Both of these gentlemen bring me to the Rafflesia world. So I have to say thank you for Pak Latif yang membawa saya ke dunia Rafflesia. It was long time I see the Pak Latif. It was, I guess it was 2007. And after this morning I met Pak Latif, it seemed to me that I am growing older, but Pak Latif growing younger. So, salam sehat selalu Pak Latif, dan selalu bahagia. I also take a look the speaker. Some of them come from UKM, University Kebangsaan Malaysia. I am the UKM alumni. It seems to me it's like a little bit reunion with friends and colleagues from UKM. So I would like to share some experience in Rafflesia and also idea of Rafflesia. The first is how Rafflesia can escape from local extinction. Next. Next. I would like to talk about a little bit of biology of Rafflesia and also pollination and insect ratio of Rafflesia and population attribute of Rafflesia. We talk about the mortality of Rafflesia, about recruitment of Rafflesia, and also population dynamic of Rafflesia. Study of population ecology is very important if we have to conserve Rafflesia. And then we talk about a little bit of life history of Rafflesia, and that and also the dynamic of the group of endophyte within host plant. And then the last one is I would like to offer the future research on Rafflesia. Next. And we take a look, it is almost 200 years ago, Rafflesia was discovered in Bengkulu. Right now, there are still mystery of Rafflesia. For example, we really do not know how the Rafflesia inoculate the host plant, how the seed of Rafflesia germinate inside the host plant. Also, how the endophyte within the host plant tend to be new birth of Rafflesia. If we take a look at the biology of Rafflesia, Rafflesia is very unique, you know, or you know about the biology of Rafflesia. There is no leaf, there is no trunk, and there is no true root system of Rafflesia. And Rafflesia also dowsy species, meaning that male and female flower come from different individuals. So this is going to be a problem with the pollination of Rafflesia. Next. Some people think that pollination takes place on Rafflesia, but from the scientific article, it is hard to find that pollination can take place on Rafflesia. First of all, the sex ratio of Rafflesia. Sex ratio of Rafflesia is going to be like 7 to 1, meaning that if you find a 7 male flower, then you find only 1 male flower. It is very difficult if you have more male flower than female flower to pollination take place. And the second one is, it is very rare to see 2 different sexual flowering take place in the same time and the same time, in the same place. This is the requirement for pollination take place if you have 2 different male and female flower in the same place and the same time. The other thing is the pollen viability is Jamilianisis is only 3 days. And the next one is if you have sex ratio more than a female flower, and then you cannot, it is very rare to find 2 flower individual in the same place and in the same time, then pollination difficult to take place. So this is become the constraint for Rafflesia to conduct sexual reproduction. So this is also become, if you take a look at the population perspective, if pollination process doesn't take place on Rafflesia, then we cannot know how the new Rafflesia will come out from the population. The next one. So this is if you take a look at several Rafflesia, the sex ratio is going to be like 3 to 45 and 1, meaning that if you find 3 male flower and then you only find one female flower. This is a very unique sex ratio that can make Rafflesia difficult to do a pollination process. Next, the other thing about the population ecology, that population size of Rafflesia is very small. In general, it's less than 10 individuals per host plant. This is several species. For example, Rafflesia arnoldii, Rafflesia camomo, and bengaluensis is less than 10 individual per tree. If we take a look at Rafflesia gadotensis, is less than 5 individual per host plant. It is very low based on population ecology. The better one is Rafflesia canteli and also Theomanensis. A city has been described new species about the Theomanensis. Maybe you can share both the population size of Taiwan. From the article is between 10 to 20 individual per host plant. If we take a look minimum viable population, it is very, very low. If we go back to animal kingdom, the minimum viable population is just 50 individuals. So less than 50 individuals, actually the species is very sensitive to extinction. So this is we have to pay attention to the population size. The small population is likely more sensitive to extinction. Next, mortality rate. Mortality rate, of course, from species to species, is very different. From one species, from one site to another site, it's very different. The mortality rate is like 40% to 100%, but I'm comfortable to put the 70%. The average mortality rate is 70%, as Pak Latif mentioned in his article. This is very, very important. We have a small population size, Rafflesia, and then we have a high mortality rate. Then these two combination is a recipe to local extinction, I guess. The next one. Next. The thing that we really little bit do not pay attention with the new bird recruitment. Actually, new bird recruitment is not many, it's a very rare recorded. For example, if you take a Rafflesia arnoldii, bird recruitment is 40%, but mortality is 64.7%. But in this condition is actually the Rafflesia arnoldii is going to disappear. And also the Rafflesia rocusonii, the mortality rate 88%, but bird recruitment is just 23%. So this species, this bird species, is going to be going to extinction. I believe that another species also has the same number of mortality as well as the bird recruitment. But I do not know if there in Malaysia is there any study on bird recruitment of the Rafflesia. Next one. So, how about the mortality and population time through mortality through the time? We have data from three Rafflesia versus Rafflesia arnoldii and also Rafflesia bengalensis and Rafflesia pacma. If we take a look, the time is less than 1 year, the population is declining for those three species. Pak Zul Asman also in the earlier presentation mentioned the declining population through the time. And also Pak Zul Asman also in the article in Royal Belum National Park indicate that there are 7 population sites, and then but they choose to 3 sites, I guess. This is situation make Rafflesia going extinction. You have a very small population size, you have a higher mortality, and you have a low bird recruitment. These two situations make Rafflesia difficult to avoid extinction. Next. Next one. So that kind of situation has been, we have evidence there are many local extinctions based on this kind of situation. First, if we take a look in Bengkulu, there are several protected area for Arnoldii, but right now they do not produce any flowering again. And we take a look in the Java, Rafflesia Padma also has a similar fate. There are several sites, and then right now registered for a few sites of Rafflesia. But how can we explain the long flowering event in Rafflesia? If we take a look at the population ecology perspective, small size, high mortality, and then low birth recruitment, then Rafflesia will go on. But we have recorded several Rafflesia, for example, in Batang Palupo, Rafflesia was established in 1930, I guess, for protecting Rafflesia already, but right now still produce flowering event. Way back in colonial time, there are three Rafflesia, Rafflesia arnoldii, Rafflesia rocusniin, Rafflesia Padma, transplanted from their original site to the Bogor Botanical Garden, I guess, in 1830, then still producing blooming Rafflesia until 1929. It's going to be like 80 years ago. It's very long story. So the last one is Pangandaran protected for Rafflesia. Rafflesia Padma established in 1935 and 1934, and right now still producing Rafflesia. So how can we explain this kind of long flowering event if we have a situation, small population size, high mortality, and low birth recruitment? Next. Next one. So go back to life history, and we take a look. If we take a look at the life history, Rafflesia consists two things. This is the visible life history and also invisible life history. What we know right now, like population dynamic of flower, but is visible one. Meyer says visible one take almost 2 or 3 years. This is almost true. But invisible one, what's going on inside the host plant, we really do not know. As I said earlier, that there are many mysteries of biology of Rafflesia need to be revealed to more understanding about the biology of Rafflesia. So this is the unknown thing that we have to take consideration for future research. The first is we really do not know how seed can inoculate inside the host plant. Also, how seed germinate inside the host plant. How endophyte grows, develop, and become new bud recruitment. We really do not know. There is still a mystery. Maybe Adit will share some research on inside the host plant. But I think this is the most important concerning about maintaining viable population. Next one. This is inside what's going on inside the host plant. The first is it takes 2 years. Mayor said that it takes 2 years from seed become new bud recruitment. But I think not to be this Mayor, because Busofi record that it needs at least 7 years to see the new bud recruitment. So I think this is one thing that we have to take a look more detail if we want to understand the biology of Rafflesia. So I believe that what inside the host plant is become a determinant factor to population size. So there are some questions: how endophyte inside the host plant turn into the flowering bud, and also we do not know right now how many buds produced during that time, during the 7 year of waiting thing. Next one. So I would like to propose what we call the pool of propagals. I believe that the dynamic within Rafflesia is ecologically important to maintaining population. If the endophyte can produce enough new bud recruitment, then population will continue producing blooming Rafflesia. For example, Batang Palupo right now is almost 100 years, still producing Rafflesia. However, if endophyte do not produce enough new bud recruitment, then Rafflesia will go to extinct. Unfortunately, we really do not know about the dynamic inside the Rafflesia. I guess this is the one thing that we have to uncover, the mystery of Rafflesia. If we can have the data of the dynamic of Rafflesia within the host plant, actually we can develop model to estimate when the Rafflesia will go extinct. But it's, right now we do not have any data on the dynamic inside the host plant. Next one. Go back. So this is about and then I think that this is the answer why the Rafflesia can produce flowering even for a long time ago. This is the mechanism Rafflesia to escape from the extinction. The next one. So if we take a look, I'm trying to imagine about the growth cycle of Rafflesia. Sometimes we see the Rafflesia but increase in number and then experience high mortality and also a flowering event, then it's going declining. And then in some time, we cannot see any flower bud in that site. But it does not mean that we cannot see Rafflesia anymore because we cannot find any bud. But inside host plant, endophyte still growing, endophyte still developing, and endophyte still producing new bud recruitment. So this is what we call a sleeping period. When you see, for example, if the Rafflesia site, for example, 3 years ago, you can see the flowering Rafflesia bud, and then right now you go to that site, you cannot see any bud anymore. This is what we call a sleeping period. And then endophyte within host plant producing new recruitment, and so on and so on. This is a cycle repeated for a long time. So this is the explanation. I guess this is the explanation why we can see the site producing blooming Rafflesia for a long time, period. And then if we in the second scenario is like in the bottom, yes, there is a cycle, bud increase in number, and then flowering and so on, and declining, and through the time the population size is become smaller, and then in the end is going to extinct. That's why I would like to say that what going on inside the host plant become ecologically important to determine the future of Rafflesia. Next one. Future research. I would like to offer the long-term ecological research permanent plot. I mean, I guess it is very rare to have long-term ecological monitoring site. I do not know in Semenanjung, Malaysia. We try in Bengkulu, but it didn't work. But this is very important to see the population perspective on the dynamic of Rafflesia. If we have a data on bud recruitment, we have a data on mortality, we have data on the population side. Basically, we can develop modeling to estimate when the Rafflesia will stay forever, or when Rafflesia will go to extinct. The other one is the seed germination and the survival and dynamic within host plant is very important to reveal the biology of Rafflesia. I am from ecology. It is not my domain to do research on inside the host plant. Maybe in the future we make collaboration research to do more comprehensive research on Rafflesia. The next one. Thank you for that. And this is the Hazelti, Rafflesia Hazelti. When the first time I went to UKM, I bring this picture, and then discussion with the late Kamarudin Matsaleh. By that time, people in Malaysia think that there was Rafflesia Hazelti in Semenanjung, Malaysia. It turned out that what we call Rafflesia Hazelti in Semenanjung, Malaysia is Rafflesia asdani. Pak Teh described the species. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.